Only thing what you should know the current gain of the circuit. If you know the current gain, you can apply that and you can simplify that impedance Z into two components. One is Zi, one at the input side, and second one is Z naught, that is at the output side. Okay, so we are decomposing common components present between input and output into a separate component at the input and a separate component at the output using Miller's theorem. See, I once again say the previous case, you see, I have a series component. So I am decomposing it into two shunt components using voltage gain. In this case, now you see you have a shunt component. I am decomposing it into two series components using the current gain formula. So you should study them logically and relate them and understand. So one configuration, if you remember it clearly, if I have a series component, I'll be decomposing into two shunt component. Shunt what will be same? Voltage. So I'll be using voltage gain. Like that you have to remember. In this case, you see I have a shunt component. I am decomposing it into two series component. In series, what will be same? Current will be same. So I am going to use current gain in my formulas. So if you remember it like that, then Miller's theorem will not be confusing to you. Why we are studying this Miller's theorem? Because we will be applying this Miller's theorem in our high frequency analysis of common emitter amplifier circuit. So at that time, if I say Miller's theorem, it will not be understood by you. So I am taking Miller's theorem before starting the derivation of a common emitter amplifier high frequency analysis. Okay. So any queries you have in Miller's theorem, you can ask. I'm going to pause for a few seconds. Anybody is having queries, please do open up and ask.
Sir, basically, why do we need Miller's capacitance, sir?
See, it is not that we require Miller's capacitance. When you analyze high frequency region in common emitter amplifier, there will be a capacitance between base and collector that will assume significance. For analyzing the behavior of that capacitance at high frequency, I'll decompose that capacitance, one at base side, one at capacitance side, using Miller's theorem for analysis. That will make my analysis very, very simple. That's it.
Okay.
Nobody wants Miller's theorem to be used always. Miller's theorem is used only when there is a component present between input and output of any network. Understand that? Okay.